Hello everyone. Today in this unlimited runtime world generation system, I am going to work on spawning animals. So here you can see I have some animals spawned around the world, and those red lines represents the places that the animals are spawned. So as the player moves around the world, let me speed up a little bit, you can see animals are being spawned all around the world. So no matter where player goes, if there is ground, animals will be there, and they will be spawned far enough from the player, so we will not see them popping out in the world. Only if I speed up, you might see that. So yeah, this is what we are going to work on today. And as we go further away, to keep the game optimized, we remove the animals that has been spawned and we have passed them, and if they are far away they will be removed. So if I eject from the player and go to the initial location, so in this area now there are no animals, as you can see. But if player come back again, animals will be again spawned in that area. So yeah, and also as the player moves around, the world is generated in front of the player, so no matter where we go, we will not run out of world. So yeah, let's see how to implement this animal spawning system today. And before we get started, I'd like to remind you, you can download the project files of this project and all other thousands of projects that I have done in my channel. So to the date, there are over 1700 videos, and for each video, project file is available for download. Link is in the description below. And let's get back to today's episode. So in case you haven't seen the previous episodes of this channel, this system, this unlimited world generation system, or the world engine plugin that I have developed, I have shared all the steps from the beginning to end until this point, so you can follow all those videos in this playlist. I'll leave the link in the description below to the full playlist as well. Here I have covered starting from how to create a mesh in the runtime, and then how to convert that into a full terrain, and how to add foliage, grass, all those things are covered in here. Okay, so this is what we have as of the end of the last episode. So here, as you can see, there are no animals. All we have is this grass, scape, and trees. So as the animal, I am going to use this simple character that I have created. So I'm not going to explain the process of creating the character because this is very simple, and also I have shown in many videos how to create a character using in Unreal. So that's not the focus of this video. The focus of this video is spawning animals or whatever the character you want. If you want, you can use third-person character as well to test this system. So in this character, all we have is this simple random movement system. It doesn't have a AI, that like a custom AI. It only has the default AI controller, and all I do is just randomly moving the character on the terrain. So if I just place one of these guys here, let me just place him somewhere over there, he's just moving around. So that's all this guy do, just moves around. So yeah, now to start implementing the animal spawner, I am going to use the base class that I already have in this plugin, this tiled spawner. This is intended to use as the base class for anything that I want to spawn and despawn in a grid around the player. So this is the same class that I have used to create this tiled grass spawner as well. Alright, so let's first create a new C++ class and go to our classes and I'll select tiled spawner as the parent class. And next, so here I'm gonna select the plugin 𝐂𝐿M_world_engine plugin, because I want this class, this animal spawner, to reside inside the plugin as a part of plugin. So I'm gonna call this tiled animal spawner and create class. Okay, now I got reload option here. So now you see tiled animal spawner header file here and tiled animal spawner C++. So as I said, this is a child of this tiled spawner class, which is this one. So in this class there are a couple of functions that I need to override, mainly this spawn object and this remove tile function, spawn object function and remove tile function. So to override them, all I have to do is copy this and go back to tiled animal spawner. Here I'll open a public section and this add over paste, but I copied and add override at the end. Similarly, I would need to override, as I said, this remove tile. So when you copy, you don't need this virtual part because we are overriding that here. Okay, now you have this prompt to create the definitions for these functions. Let's go ahead and do that. So now the first thing we need is a way to tell this class what are the animal classes that I want to spawn. So to hold that data, so it may not be just the animal class, it may be like other parameters such as herd size, so some parameters that defines in what height range or in what areas this animal should be spawned, things like that. We may not need them now, but in future when we extend the system we would need them. So to keep room for such improvements, I'll define a use struct here. Now we need a way to define a variable to define the classes that I need to spawn, so the animal classes. So for that, here let me start a public section and add a u property, because I would need to update the values of this variable that I'm going to define from the engine. So I'll make it edit anywhere and blueprint read write, and also I'll define a category and else. So I'll name this variable t, oh, the type is t subclass of, because these animal classes that I'm going to define are going to be subclasses of a actor. So when I define it as a subclass of a actor, we can use either a actor class or a pawn class or a character class, so whatever I need, whatever that is a subclass of actor class. So I'll call this animal class. Right, I think that's all I need for now. Maybe later we would need something like, if this animal is going to be a herd, I might add a integer herd size. By default I'll leave it at 1, but for now I'm not going to think about herd behavior. Okay, now let's go back here and compile and make sure everything is working. Yeah, live coding succeeded. Okay, so we have this tiled animal spawner. Now if I go back to engine, I have this tiled animal spawner here under plugins, 𝐶LM world engine, plugin content, C++ classes, world engine public. So here right click on this animal spawner and create blueprint class based on the tiled animal spawner. So as the destination of the blueprint, I'll again select the plugin pp folder. I forgot to give a name, but that's okay. I'll name it BP tiled animal spawner. For now, these variables are coming from the parent class, which is tiled parent class of the tiled animal spawner, which is tiled spawner. So we can use these to define the grid parameters, so cell size, subcell size, things like that. Now let's go here and let's add our first variable into the tiled animal spawner. So first thing I'm gonna need is, let me copy this uProperty specifier. I don't want to type it again. We would need an array that defines the animal types. So the array, this should be in the type of f animal type. This is struct that I just defined above. I'll call it animal types table. Okay, now if I go here and recompile, build failed. Blueprint read write should not be used in private members. Oh, sorry, I forgot this keyword. Okay, now let's see here. Now we have animal types. Let me add one element, and here I'll add what's the ch para. That's the animal blueprint I have, which is this guy. Okay, now let me place this tiled animal spawner in the world, but for now it does not do anything. And also note that we have by default tick interval is 3 for this animal spawner, and I don't want by default this tick to be enabled, so I'm gonna disable it and then give a delay of, let's say, 0.2 seconds or maybe a little more than that, and set tick enabled. The reason I do this is because it takes some time to generate the landscape, so only after landscape is generated we should attempt to spawn animals, otherwise they will fall below ground. But still no such spawning happens yet. Okay, so this spawn object is already been called, because as this is a subclass of the tiled spawner, it calls this spawn object from this update tile function here. So what it does is, let me explain. Here for the animal spawner, I have this cell size. I think we can make this bigger because we don't need densely populated animals like grass, so this could be, these things should be larger. So subcell size 10,000, cell size 20,000. So for each of these cells I get a call to this spawn object. So that is all, that part is already working, should be already working. Now to test that, here let's draw a debug line. So first I add a effector I'll call it spawn location, and I'll take it from this hit result we get. This is the hit that we do to the ground to determine the ground location. So hit dot location, and using this, let's draw a debug line and get world, and the start point is spawn location and endpoint is spawn location plus f vector up vector multiplied by, let's have a long line with 10,000 units. And the next thing is color, f color red. And the next thing is persistent line. No, it doesn't have to be persistent. What's next? Lifetime, let's say 20 seconds should be enough. Okay, let's see if this is working. So before we spawn any animals, let's just take a look at where they are going to spawn. So see, these are the places that animals going to spawn. Okay, so it is working. So now what we have to do is, in this location, spawn in animals. But before spawning animals, we need to make sure that this location, hit location, is above sea level. We'll just hard code the sea level. I'll just assume it. If, let's say, hit location z is let's just assume sea level is 250 units. For now I just don't want to connect this with the world engine, because in the world engine, this world engine blueprint, we already have a sea level defined. But let's just focus on spawning part first, then let's focus on connecting it with the rest of the system. So if the location is below 250, because I don't want them to be on the beach also, maybe they should be on the ground in the green area. So if this is the case, I'll return, because I don't want to spawn. Also, I need to check one more condition. In our grass spawning system here, we use this supported surface type, which defines the physical material layer, and I use this to make sure that grass is spawned only on green areas. I have defined in the settings, in case you don't remember, surface types, this grass surface type, and then I have assigned this physical material which uses the surface type grass into the landscape material. Yeah, actually it doesn't determine if it is grass, it only determines if it is the landscape that we are hitting, the line trace. So we can avoid things like treetops when we spawn animals. So I'll do the same thing for the animal spawn as. For that, let me paste this u property t_enum as byte e physical surface supported surface type, and then we use this when we spawn the objects. We check if the hit has a physical material, we check if the surface type is not similar to the supported surface type. So if it is not similar to the supported surface type, we again return. That means we don't spawn any character there, any animal there. So let me add that also here. Save everything and compile. All good. Animal spawner. Now we should have supported surface type. I'll select grass. Perhaps I should have called it landscape other than grass. Now if I play, I don't get any lines on the sea, only in the ground. Okay, yeah, not on any treetops as well. Good. Alright, now to spawn animals. So for now I only have one element in the array, but still I'll do it like this. For int I starting from 0 to animal types dot now. For all I'm gonna iterate through all the elements in the animal types, and from each type I'm going to spawn animals. So in order to spawn actors, we need something called spawn parameters. I'll name it spawn parameters, and here there are some settings that we need to define. Spawn parameters owner is this is a spawner, and spawn parameter be no fail determines whether spawning will not fail if certain conditions are not met. If true, will not fail because of the class being spawned. Static is true, so I'm not going to read that. So you can refer to the documentation, but you just have to make this true, otherwise you're gonna get null actors. Okay, also we need, in order to spawn location and spawn rotation, and also what class the actor we need to spawn. So class can be retrieved from these animal types. As for the location, we already have spawn location, but I don't think we should use this hit location exactly, because we need to account for the height of the character's capsule as well to the middle point. Therefore I'll add vector up vector maybe 200 units upward from the ground, so the actor will be spawned above ground and they will fall down, but that's fine. Okay, now we have the spawn location. We also need, now that I maybe let's not vector, rotator, spawn rotation. We can actually initialize this x0 and yaw. The second one is yaw. First one is pitch. Pitch should be 0 and yaw should be, well, random. So fmath, it could be facing any direction. Rand range 0 to 360, and roll also needs to be 0. Okay, so that's the rotation, a random facing direction, and now we have everything to be, yeah. So now let's spawn the actor. Let's put the return actor to actor pointer, spawn actor. So this is how we spawn. Get word spawn actor from the type a actor, and we need to give spawn parameters. Wait, no, class, and then it's class, and then location, rotation, and parameters. So as for the class, I'll get animal types and ith element, the element that we are currently iterating, and then animal class. Then I'll give spawn location, then spawn rotation, and then spawn parameter. Okay, that's all. Now what now? Now let's save and compile and see. Successful, right? Let's hit play, and yeah, you see now we have animals spawned and they are roaming around, so half of the work is done. Yeah, but even if I go further away, even when the landscape is removed, animals will be there. So further I go, more animal instances will be in the world, which is something I want to avoid. So we need to keep a reference to the animals that we spawn, and then we need to either relocate them, like using the object pooling pattern, or I need to destroy them. But the better way to handle this would be object pooling, but I'm not going to pool the animals right now. I'm just gonna destroy them, but in the next episode we will see how to pull them, because I want to keep this episode shorter. Okay, so to hold a reference to the animal objects that we have spawned for a tile, we might need to know which tile this animal belongs to, but here we only get this hit result. Therefore, we might need to give a reference. We might need to pass the tile center. That means in this tile spawner, in the update tile, we call spawn object, and here we have tile center, which is the center location of this bigger tile. So what I can do is, let's go here and I'll copy this parameter and I'll add it to this spawn object. So TRA A actor spawned animals, F tile animal data. Now using this struct, I'll add a new variable. I should have renamed this to animals. Okay, so this time I would need a map, because I'm gonna keep an array of animals that I can be accessed using the location of the parent tile. So tmap, key type is fvec, and the value type is the above defined struct f tile animal data. And what should I call this? Actors of tile. So should I call it animals of tile? Yeah, that sounds better. Clear. Okay, now let's go here. So as we add new actors, if we get a valid actor, if spawned actor is valid, because for some case we might not spawn an actor successfully, so better to make sure we have a valid actor. Let's do it like this. If we don't have a valid actor, let's continue this loop. That means we will not execute the rest of this loop. If we have a valid actor, we will continue to the rest. So now we need to check if we already have an array that holds references to the actors in this tile that we are currently spawning animals. So for that, f tile animal data, I need to find animals of tile. Find this tile parent tile. If we get a valid reference here, that means we already have a structure that holds animal references. So if animal data is valid, all we have to do is animal data. From this we can access spawned animals, and into that we can add this newly spawned actor. If not, that means we would have to create this structure and add to the animals of tile. So we can do it like this: animals of tile, add key is parent tile center, y doesn't autocomplete, parent tile center, and then an array of spawned animal actors. So for now I only have one, because this is the first actor that this tile is going to have. So we can just spawn actor. Alright, we can add it like this. Here we have defined an array. So once I do this and I have kept this array visible or from the blueprints, so if I compile, failed, sorry, this should be like this: f tile animal data, then inside that I need to add the animals array. Okay, yeah, it's successful. Now here if I select animals, now I should see here this animals of tile. So for each tile we have this spawn animal reference. So now we can use this to either destroy or relocate or add them to the pool when the player moves away from that tile. Why did it crash? Okay, let's find it out later. Now let's do remove part. So in order to remove, just like before, we need to check if we have the data. So we can do this, and instead of parent tile center, now this time we can use the tile center. And if yes, animal data is present, we need to destroy. Let's just destroy for now. Animal data, spawned animals, count animal data, spawned animals I, and then set lifespan. I'll set to something like 0.1, so they will be destroyed. And after all the animals are destroyed, I'll again access animal data, spawned animals empty. I'll empty the array. Alright, let me play. Okay, here we have the animals spawned. Now let me fly away and check if the animals are destroyed. No, it's not far enough. Let me move further away. Okay, now let's see. Yeah, see, now I don't see any animals here. Alright, so the system is working. Now let me see. Oh, it didn't crash this time. But yeah, I will debug and find out what caused the crash previously if I encounter it again. So for now, I think we can stop this episode. So we can infinitely go around the world. Let's go to the other side. Yeah, here we have our animals. Okay, cool. I'm gonna stop this episode right here. Thanks for watching. Don't forget to like, subscribe and share. As always, updated project files will be available for the download in the Patreon page. Link would be in the description below. And see you in the next episode. Goodbye.